Alrighty, in this video we are going to do more practice on parametric equations and vector value functions. So we're going to do probably number 1 and then number 2 and then call it a day because there's a lot more that you guys can do on your own. So number 1 says, a particle moving along the curve C in the xy plane is at position x of t, comma y of t, for 0 to pi, where y of t is equal to 2 sine of t. dx dt is equal to e cosine of t, and x of t is not explicitly given. At time t is equal to 0, the particle is at the point 1, 0, and the curve is shown in the figure. All right, part A. Find the velocity vector at time t is equal to 1, and find the acceleration vector at t is equal to 1. Now, it's going to be very important for you guys to understand what's happening here. You have the y position, but then you have the derivative of x with respect to t. Okay, so for part A, whenever it says find the velocity vector at time is equal to 1, what you want to do is probably take the derivative of 2 sine of t to get that to help you. But first, we got to do dx dt because that's the first component. In this case, we want e to the cosine, well, let's actually do this. E to the cosine of t, comma 2 cosine of t. Okay, so t is going to be chain. So that's going to be negative sine of t, e to the cosine of t, negative 2 sine of t. Okay, and then at 1, you're just going to plug in all of that. E to the cosine of 1, we don't know what that is, so just keep it like that. And then we have 2 cosine of 1. Once again, we don't know what that is, so just keep it like that. Same thing with a of 1. So that's going to be negative sine of 1. E to the cosine of 1, comma negative 2 sine of 1. Keep it like that, okay? Don't do anything stupid. Just leave it like that and call it a day. So that's your answer. All right, part B says, find the first time t in the interval from 0 to pi for which the speed of the particle is 1.5. Well, if the speed of the particle is 1.5, and we know that the equation for the speed of the particle is the square root of the derivatives, right here, I'm going to set the speed here, the derivative, equal to 1.5. Lucky for us, we already know what the derivatives are, so what I'm going to do is just plug in for y1, e to the cosine of t, and for y2, 2 cosine of t. And then that's going to help us a little bit. So going off to my handy dandy calculator, I have e to the cosine of t, and then I have 2 cosine of t. Okay. Now, what I'm going to do is probably use the equation solver. Oh, just kidding. This calculator does not have the equation solver. Bummer. Well, instead of using the equation solver, that's okay. We could just use good old graphing calculator and call it a day. y1 squared plus y2 square. I don't really want to see y1 and y2 just because they're kind of irrelevant in this case. I'm also going to change my bounds so that it is from, let's say, 0 to pi, since that's my interval. And then since this is equal to 1.5, I want my y min to be, let's say, 1 and my y max to be 2, so that I can clearly see where 1.5 is. Gonna graph, and then you see that. Now, remember that I only want the first time t. So here, oh, what did I do? Did I do 10 pi? Okay, sorry, I don't know what I did. Here, I want the first time t. So if I go to second calc, and I find my intersection, the intersection that I want is right here. That's going to be 1.25447. So 1.251 t is equal to 1.25447. C says, find the coordinates of the highest points of the curve C for 0 to pi. All right, so whenever it says highest point, we're thinking about maximum. In order to think about maximum, let's think about how I need to find dy dt and set that equal to 0. In this case, we have 2 cosine of t is equal to 0. When does that happen from 0 to pi? Well, if I were to use my unit circle, it's going to be right here. That's going to be at pi over 2. So t is equal to pi over 2. Okay, so if I have t is equal to y over 2, pi over 2, I am going to find my x component and my y component. Notice how my x component isn't explicitly given, so I'm going to have to take the antiderivative from 0 to pi. Now, we all know that at x, when t is equal to 0, the position is already at 1. So I'm going to have 1 plus the integral from 0 to pi of x prime of t. In this case, that's just e to the cosine of t. And then to find my y value, since the y value is explicitly given to us, we're just going to plug that in. So 2 sine of pi over 2. In this case, we know that pi over 2 is going to be 1. So 2 times 1 is just 2. The only thing that we kind of really need to look for is the x component. So to find the x component, I'm going to do 1 plus the integral from 0 to pi over 2. And then this is my x component. So that is going to be e to the cosine of t, which is y 1. And that's going to give us 4.1043. 4.1043, and then 2. So this right here is going to be the highest point on the curve for 0 to pi. Which, of course, you kind of see it right here. So that kind of justifies our answer. D says, find the position of the particle at time t is equal to pi over 2. And plot twist, if you haven't noticed, because we took the derivative of this and then we found out that t was pi over 2, this right here is also the same thing as my highest point, which means that part C and D are going to be the same answer. Except for part C, it's talking about highest point. For part D, it just tells me find the position at some time. E says find the total distance. So technically we're going to be using the arc length formula if that helps you memorize that. So we have 0 to pi, and then we have x prime of t square plus y prime of t square dt. Now for my y1 and y2, it's already in terms of my derivatives because I already took the derivative of 2 sine of t to be 2 cosine of t, so that's great. Beta. Okay. This is from 0 to pi. And then I have the square root of y1 square plus y2 square dx. That's going to give me 6.034. That's my total distance. F says, find the point on the curve C where the slope of the tangent line is 1/2. So I'm going to have 1/2 is equal to dy dx or dy dt over dx dt. So that's going to give us 1/2 is equal to dy dt is my derivative, so that's 2 cosine of t. And then dx dt, they already gave us, was e to the cosine of t. All right, so you're just going to put that into the calculator. So we have 1/2. Oops. We have 0.5. And then we have 2 cosine of t e is the cosine of t, which I could technically do y2 here. I don't know why I didn't think of that. Oops, no, y1. Oops. Okay, let me do that again. So that's going to be y2 over y1. Okay, graph it. Probably change your windows first because we want my y minimum to be 1/2. So this should be, let's say, 0. And let's say that this should be 1. X, okay, we could just leave it from 0 to pi. Graph it. You have your intersection. That is going to be 1.25, maybe? Let's see. Trace, intersect these two right here. So they intersect at 1.205. 1.205. So t is equal to 1.205. And of course, notability is acting up. Great. All right, last one. I know I said that I was going to do 2, but 1 was a lot for me. Find the second derivative at t is equal to 1 and use it to determine whether the curve is concave up or concave down at the point when t is equal to 1. Remember that my second derivative, I'm going to be using a little bit of chain. So in this case, I'm going to have d dt dy dx over dx dt. Well, we know that the derivative of dy dx is 2 cosine of t over e to the cosine of t all over dx dt, which we know to be as e to the cosine of t. And we want to figure out that value. So 1. All right, so in order to do that, we know that, let's go to my graph, that we want to find the derivative, nth derivative of y2 over y1. Because remember that y2 is going to be my dy dt. That's 2 cosine of t. I think I have 2 cosine of t to be y2. Yep, okay. And then we're going to evaluate that at x is equal to 1. But remember, that's just my numerator. What I'm also going to do is evaluate e to the cosine of t. Remember, that's dx dt. That is y1. So I'm going to evaluate y1 at 1. Then I'm going to divide those two. That's going to give me negative 0.2625. Now, because my value at t is equal to 1 is negative, this means that the curve concaves down. Curves concaves down at t is equal to 1 because the second derivative is negative. Of course, you'll see similar problems on the rest of the packet. Probably focus on the release of our Qs, so something like 2022, something like 2021, something like 2016, 2015. There was also a particle motion problem in 2023, so the likelihood of you probably seeing a particle problem FRQ on this year's exam, very likely. Who knows? But that's that. All right, so this is it in terms of Unit 4A. You're going to take your tests, and then we are going to talk about polar in 4B.